Welp, a rabbit's been pulled from a hat, and now I've got egg on my face. In a move that very much surprised yours truly, many automakers have announced their commitment to adopting the formerly proprietary Tesla charging connector for their North American market vehicles. A connector which, assuming things keep going in the direction they appear to be going, is on its way to being an honest-to-goodness industry standard, complete with its own SAE-J number, J3400. And now it's your turn to be surprised. I'm all for it. Yes, although I am personally quite annoyed by this outcome, that's only because it's a hit to my ego. I really didn't think this was going to happen, which you can definitely tell by some of my past assertions. But now that we know more of the details, assuming they hold true, which is a monumentally important caveat to this entire video, this is welcome news. Ultimately, I just want the industry to coalesce around a single charging plug. And, well, I was wrong about which one would win the plug wars. At least, probably. The dust hasn't quite settled yet, and things could change, but honestly, the Tesla connector is better. Take note, Tesla stans. I said it. And with what has recently come to light, there really isn't a downside to the rest of the industry adopting the connector standard hereafter known as the North American Charging Standard, or NACS, or NACS. I have 4 things I'd like to accomplish in this video. First, explain what makes the NACS connector uniquely suited to use here on this continent. And just to lay this out up front, this is only a North American development and standard. If you're somewhere else, this video doesn't really apply to you. Second, I want to talk about the change to the standard that's making me pretty chill about all this. Third, I want to address why automakers are making the switch, and why they probably shouldn't count their chickens before they hatch. And fourthly, I will get a little bit on the spicy side and share my broader thoughts and opinions on the state of the third-party charging industry. I will freely admit that on the whole, Tesla always had a better plug, but I really hope we don't try and copy everything they do. First things first, what is NACS? Why is it different from the industry standard known as CCS? And why is North America uniquely suited to use it? To save time, I'm going to keep this explanation pretty surface level. There are links to other videos of mine if you want to learn more. This is the charging port on my car. This connector is generally known as J1772, and it's for AC charging. It has 5 pins, 3 big ones for handling power, line 1, line 2, and ground, plus 2 small ones for communication and control. This connector has been around since 2009, and it supports a maximum of 19.2 kilowatts of power, though few cars actually accept that much. Due to practical constraints, charging through this port just isn't that fast, though it doesn't need to be. The whole idea of AC charging is that it's really simple to implement. What we call car chargers are really just smart power cords which deliver the same AC line voltage that runs through your walls to the port on your car. The actual charger module, meaning the thing with electronics that converts the AC power into the correct DC voltage for charging the battery pack, is part of the car. That makes wiring up a new AC charge point for an electric car very straightforward and inexpensive, and it will work with any car, regardless of battery pack size, nominal pack voltage, cell chemistry, or manufacturer. The charge speeds you can get through this port are more than enough for charging at home or work where your car will sit for several hours at a time, but they aren't anywhere near fast enough for taking a road trip. Battery packs of the size found in modern electric cars need something on the order of 150 kilowatts to charge quickly, and even more if we want charge times to get down to the 15-minute range. Luckily, we thought of a solution. Under this little flap lie 2 gigantic power pins. These are there to facilitate high-powered direct current charging, and to accomplish this, we in fact do hook the car up to an external battery charger. An off-board DC fast charger will connect through these pins directly to the car's battery pack. That charger can be figuratively and literally huge, with a massive grid connection capable of delivering 350 kilowatts or more. Using a defined signaling protocol on the communication pins of the charge connector, The car's battery management system will request a specific DC voltage and current from the external charger, and that charger does as it's told to juice up the pack. With this technology, the only meaningful limit to charge time is, well, the state of battery technology. The addition of these DC pins gives this charge connector its name, CCS, which stands for Combined Charging System. It is a J1772 AC port combined with two DC pins below it. In Europe, this same exact augmentation was done to the IEC 62196 Type 2 connector, also known as the NACS connector. Although the North American CCS1 and the European CCS2 share a lot of the underlying technologies, the AC portion of the connectors are different, thanks largely to the fact that European homes are often wired for three-phase power, which is just not a thing that happens here. Every consumer device, including large electrical appliances like kitchen ranges or, yes, electric vehicle charging equipment, is single-phase only, so our AC charging connector only supports single-phase power. And yes, I know about J3068, but I'm ignoring it for this video because for all practical purposes it just doesn't matter. Look that up if you want to. But then, there's Tesla. When the Model S was getting planned, CCS didn't exist yet. In fact, in the very earliest days, neither did the J1772 connector. So Tesla came up with their own thing. And this is that. Or at least one side of it anyway. This is an adapter I have to switch between Tesla's connector and J1772. And what you're seeing here is the inlet side of the connector, normally found on a car. If I manage to make it to a destination charger location to get footage of the plug side, you're seeing that now. Now you'll notice it has the same 5 pins as the standard J1772 connector. They even have identical functions. But 2 of them are a heck of a lot larger than the rest. They're not just girthy, they're also quite long, about 30 millimeters. If you haven't already guessed what's going on here, Tesla did a sneaky and uses the same 2 power pins for both AC and DC fast charging. These power pins are massively oversized for AC charging, as in that case, line voltage is sent to the car's onboard charger through these pins, which does the DC rectification and voltage boosting before sending it into the battery pack, just like a car equipped with J1772. But when DC fast charging, or as Tesla calls it, supercharging, a contactor in the car closes which shunts these big pins to a set of beefy cables that go right to the car's battery pack, and the external supercharger now shoves electrons in all on its own. It's a very clever system, I must admit, and importantly, it only really works because we only have single-phase AC charging here. The NACS connector is conceptually identical to the AC-only J1772 connector. In fact, for AC charging, it even uses the same signaling protocols on the 2 communication pins. The only difference between these 2 plugs is the hilariously large AC pins, which do DC double duty. This scheme couldn't really be done while also supporting 3-phase charging, at least not without redesigning the Type 2 connector. And that's why the Type 2 connector would get the exact same DC pin augmentation that we see here with CCS1. Now, as clever as Tesla's idea is, it's not entirely without downsides. With CCS, the AC and DC sides of the connector, and thus car, are completely isolated. The AC pins go to the onboard charger, and the DC pins go to the battery pack, so it's impossible for the wrong voltage to go to the wrong place. Combining them, as Tesla did, requires a little more consideration on the car side to make sure wires don't get crossed. But, in fairness, it's not all that much. Adding a contactor to the onboard charger would allow you to isolate it when DC charging, or you could also design the onboard charger to tolerate having DC pack voltage on its input side when fast charging, which is what Tesla currently does, if my understanding is correct. But combining those 2 functions also has a lot of upsides. The largest one being the smaller connector size, which makes handling and inserting the plug much easier, especially on DC charging. Making things even easier is the connector's shape, which is somewhat self-aligning, helped even further by chamfering on the inlet side. The latching mechanism here is also flat out much better. If there's one thing I've never liked about J1772, it's the external mechanical latch that floats above the actual mating surface of the connector. It wasn't much of a problem in the early days, but when DC fast charging came along, a means of locking the connector to the car became necessary. That was done by way of a simple bodge. Often a pin will stick out just above the latch, preventing it from moving. I mean, it does work, but it's never felt all that secure, and we have seen plenty of broken latches on public charging equipment, which is annoying at best and a safety hazard at worst, as it will prevent the connector from actually locking. The NACS connector uses a much more elegant system. There's a recess, or hole, on the plug that a pin on the inlet side will catch. It's a lot more mechanically robust and eliminates moving parts from the plug side. The car still needs some sort of actuator to release that pin so you can remove the plug, but so does CCS, so it's no worse. The only thing that I find a bit unsettling about this latch design is that a dead car could potentially become stuck to a charger if it can't release the handle. But there are ways around that, like the manual release lever you'll find in my car behind this little cover in the cargo area. Note to every car designer and engineer ever, clearly marked manual overrides for electronic latches are a good thing, and for the love of all things holy, please do not design them out to reduce bill of materials. Thanks! Now, before I move on to the section where I talk about the change that's making me pretty chill about the switch to NACS, I'm sorry, but I do just need to refresh everybody on the timelines here. I can't help it. I didn't think other automakers would be interested in Tesla's little connector for two related reasons. First, this was proprietary, and Tesla retained control over it until late last year. And yes, people are going to argue with that in the comments and insist that Tesla offered the use of their connector and indeed charging network as far back as 2014. But that offer came with many strings attached, which is demonstrated most clearly by the fact that nobody ever took them up on it. And second, because it was proprietary until last year, we didn't really know anything about its capabilities other than what Tesla was kind enough to tell us. CCS, meanwhile, had published specifications. Wild, I know. And guess what? It was more powerful than Tesla's connector had demonstrated. In fact, in terms of charging stations that are actually on the ground, it still is. The DC pins of CCS can handle 500 amps, and they were designed to support up to 1000 volt charging, which was crucial for automakers considering 800 volt battery architectures. That high current and high voltage allowed for 350 kilowatt CCS stations, and they've been on the ground, albeit in small numbers, since 2017. Meanwhile, Tesla's version 3 supercharger, which only supports a maximum of 250 kilowatts, didn't come out until 2019. So, for literally half a decade at this point, the choice for other automakers was between a connector controlled entirely by one of their competitors, which had only ever demonstrated 250 kilowatt charging, and a connector controlled by an industry standards body that is spec'd for 40% higher power output, supported 800 volt battery architectures, and all while retaining compatibility with the existing level 2 AC charging equipment. It was perfectly rational, and I'd argue correct, for other automakers to just ignore Tesla's connector. However, three significant barriers have now fallen. First, Tesla actually, for realsies, released details on their connector's design. Last November, they announced that today we are opening our EV connector design to the world. We invite charging network operators and vehicle manufacturers to put the Tesla charging connector and charge port, now called the North American Charging Standard, on their equipment and vehicles. I will add that whether they've actually released their patents on the connector is unclear. I am not a lawyer and my search was inconclusive, but given that the SAE is taking on the connector as a standard, I will assume in good faith that they have. Second, and relatedly, we now know the connector can support 1000 volt charging. This was a giant open question for years, because to this day, none of Tesla's cars have 800-volt class battery packs, and so we've never seen their connector pushed beyond about 500 volts. Through a small and backward-compatible revision to its design, which insets the conductors a little further into the connector body, it now does indeed support 1000 volts. Interesting that they had to redesign it though, isn't it? But at least they did. I am still very skeptical of Tesla's claim that the connector can handle 900 amps, but it does seem capable of handling 500 just fine, so it is at least on par with what CCS can do. The third thing that's changed is what's making me most at peace with the push to standardize on NACS. Going forward, NACS will speak the same language that CCS does. Up till now, Tesla superchargers communicated with Tesla cars in an entirely locked down and proprietary fashion. But as they have made moves to turn their plug into a real standard, they've decided to add support for the same communication protocols that CCS uses. That means that, eventually, the only difference between a car with a CCS port and a NACS port will be the port itself. And that means simple adapters can be used to switch between connector types. As of this writing, that's what the companies that have announced their intention to switch charging ports will be providing to their customers with CCS-equipped cars. Once a few things regarding billing and whatnot get sorted, they'll be able to rock up to a Tesla supercharger using the adapter and juice up. Now, as great as this is, there are some cans of worms here. Because CCS separates the AC and DC sides, drivers will need to carry two adapters, one for DC fast charging and the other for AC charging, like this one. That is a little confusing and leads to some potential concerns regarding what would happen if you use the wrong adapter. However, there are a lot of checks that happen both on the car side and the charger side before contactors get closed, so this may not be a problem at all in practice. But it is something to be aware of, and I hope a sensible means of detecting that the wrong adapter is being used is put in place. The other can of worms has to do with how much current such an adapter can safely handle. They're going to have relatively short links inside of them, and they could in theory simply be huge aluminum rods or something like that, so I am pretty certain handling 500 amps won't be too much of an ask. But that leads us to the other thing. Tesla has in the past and to this day sort of just ignored the conventional current limitations of a given conductor. Now, I've actually come around to agreeing with that practice. A hard and fast current limit makes sense for the wiring in your home that runs within walls and may span dozens of meters. But you can safely exceed a current limit for short periods of time, and often by rather large margins when the conductors are relatively short. Tesla's approach has been to put temperature sensors in strategic places and monitor how hot those conductors are getting. And so long as they're not getting too hot, then they go ham. I used to think this was pretty haphazard, but I'm no longer bothered by it. Again, Tesla stance. Mark that down. But in a land of adapters, I can see that strategy becoming problematic. Maybe the thermal conductivity of the links within the adapter body will be sufficient for sensors in the handle and car to detect overheating, and thus I have no reason to worry. But maybe it would be smarter to know whether an adapter is in use and limit the current to some safe number. Won't really matter to me since I have an 800-volt car which peaks at about 300 amps despite sucking down 240 kilowatts. But I figured I'd bring this up in case nobody's thought of it. Anyway, with a reiteration of the monumentally important caveat from the beginning, so long as the communications remain the same and passive adapters will allow people to charge on either plug, there's really not much of a reason to be upset here. And I'm genuinely not. Eventually I'll grab one of those adapters if I need to, and having a CCS-equipped car will be nothing but a minor inconvenience. Assuming, that is, CCS is in fact going away, which is likely but by no means certain quite yet. So now, why are automakers suddenly itching to make this switch? Well, there's a pretty simple answer. The CCS charging networks available here in the US all kinda suck. There's only one complete network, which lets you travel anywhere in the country, which isn't even that complete, sorry the Dakotas, and that network doesn't have a great track record. I've personally never been stranded by it, but back in April, I went on a trip in which, to start the chargers, I had to sign out of the Electrify America app and sign back in at every single stop. And more than half of those stations had broken NFC readers, so I couldn't just activate the chargers by tapping my phone. It wasn't great, and that experience is happening to far too many owners of new EVs. Meanwhile, the Tesla supercharger network largely just works. It's not perfect, no, but most locations have far more redundancy than any EA station does, and the overall experience is excellent. However, I think automakers are in for a surprise if they're not careful here. The problems that the CCS networks have experienced have almost nothing to do with the connector itself. In my travels with my Hyundai, I have experienced almost no charging issues. Once I manage to activate the charger, that is. So long as I can get to that point, which is often a lot harder than it needs to be, I simply plug it in, and it has worked with only a few exceptions, and every one of those was due to the haphazard way that CCS stations are configured, which led to a poorly aligned plug which didn't latch correctly. While that itself is a problem, it's the least of the issues we see. The main problems with CCS networks are poor maintenance, horrible uptime, largely terrible apps which are often the only way to start charging, and last but definitely not least, a lack of interoperability testing and certification when new car models get released. Let me go through those one by one, starting with maintenance. The fastest DC fast chargers have liquid-cooled cables. That allows those cables to have thinner than normal conductors, which in turn allows them to be lighter and easier to handle. This is really neat, but loads and loads of chargers are out there in which the liquid cooling part is broken. When that happens, the charger will derate itself to stay within the safe limits of the conductors, which tends to result in abysmally slow charging speeds. Making this even worse, until quite recently some networks didn't even warn you that the charger you were about to plug into had cable cooling issues, so it was a fun guessing game whether you would get the advertised charging speeds or not. Electrify America has finally begun indicating which chargers might be power limited in the app, but I can attest to this not being entirely accurate. That's certainly the most common maintenance issue that I've experienced, but it's by no means the only one. There's a lot of equipment out there with power modules that are starting to fail, leading to reduced output, weird surging behavior, or entirely knocked off chargers. Cables will get cut by vandals and the response can be far too slow. As mentioned before, latches on the connector can fail, which I've seen several times, and installation breakdown can lead to failed isolation tests, which takes individual cables or entire chargers offline. This sort of wear and tear is to be expected, but apparently most charging providers just don't have the maintenance teams or infrastructure to actually take care of it in a timely fashion. Relatedly, there's the whole uptime thing. As I write this, 3 stations around Chicago are entirely offline. That's not great, and plenty more locations have at least one charger that is dead. That's not a big deal when your site has 8 or more chargers, but most of Electrify America's locations have only 4. A single charger going down in one of those locations results in a 25% loss in capacity, which is just not acceptable. Now, in fairness to EA, they started their infrastructure rollout back when charging equipment manufacturers were just getting started themselves. So they have a whole bunch of legacy hardware from various different companies out there, and that makes their operations uniquely challenging. But that by no means is reason to give them a pass. Then we have the apps. Whether they refuse to keep you signed in or just flat out don't work, it's not a great feeling to be relying on a Jenga tower of an IT stack and working cell service to make it to your next location. Electrify America does at least include credit card readers on their fast chargers, but they didn't pick the most robust of units, which was brave considering their chargers are largely just out in the elements. app activation might be a necessary evil for banks of level 2 chargers, but given how monumentally expensive DC fast charging equipment is, in my opinion, a robust credit card reader, or at the very least an actually working NFC reader for contactless payments or Apple Pay or whatever, is a must. And if you're thinking plug-in charge is a great solution, well, I have differing thoughts, which I'll get to later. And then we have the interoperability testing, or lack of it. In part because the CCS protocol is a hodgepodge of weirdness, there are many opportunities for bugs to show up in the back and forth between car and charger, which can lead to a failed charging session. And for whatever reason, automakers have largely just left third-party charging providers to find those bugs all on their own. Which is very dumb and bad. Everybody should be loaning their latest models to the likes of Electrify America, EVgo, ChargePoint, etc. before they even make it to customers. But apparently, this rarely happens, and those charging providers have to find somebody with the latest cars and hope they'll be kind enough to swing by for testing. So, great job, automakers! You did this to yourself, at least in part. I know I'm repeating myself here, but the CCS connector itself had nothing to do with these issues. Simply putting a NACS plug on the end of the same cable won't magically fix the charger on the other end or the company that runs it. The woes of CCS are almost entirely due to bad management on all sides that doesn't seem to understand the importance of providing a reliable and good charging experience. That's what Tesla gets right, and Tesla does indeed deserve massive kudos for sidestepping this problem and building out their own charging infrastructure. But that's the reason I'm cautioning automakers and, well, really everyone hoping the NACS connector will be some sort of panacea. It will be nice to have a better connector, sure, but the connector is not what's wrong with the third-party charging industry. Not by a long shot. Still, I welcome the switch and think it presents a true best-of-both-worlds situation. My beef with the Tesla connector and their whole charging ecosystem was always that it was a proprietary connector which functioned, intentionally or not, doesn't matter, to lock out any other vehicles from using their infrastructure. I also didn't exactly like the idea of the same company that sells you the car being the one to sell you its fuel to use it, and was super concerned that a landscape of Tesla-only, Ford-only, and Volkswagen-only charging spots would become the norm. I was honestly pretty disturbed by how few people seemed to realize what a dark place we'd be in if we allowed that to happen, and that's why I was totally cool with letting charging networks grow organically and compete with one another. Regrettably, that just didn't happen fast or well enough. When we get right down to it, the CCS rollout was botched and way too slow. And since there really aren't that many CCS chargers in the wild yet, if there's a time to abandon that connector, it's now. I mean, I was saying that about Tesla's connector back in 2018 because I figured CCS station rollout would accelerate beyond the pace at which Tesla could go, but it just didn't happen. I was wrong, and here we are. Now that the SAE is taking NACS on and Tesla has apparently relinquished control of it, combined with the fact that they're inviting other drivers to use the supercharger network, well, my beefs are gone. Mostly, anyway. I realize I've left a pretty big hole in the script when it comes to competition among third-party charging providers. To make up for that, here's some footage of puppies. I might have made it sound as though switching connector types means other automakers are handing a charging monopoly to Tesla. However, that's definitely not what's happening. In the short term, I imagine Tesla's going to be a very popular charging network, but in the long run, this is ultimately good for competition and consumers. CCS networks have been so terrible precisely because they don't compete with Tesla. The drivers they provide charging to cannot access Tesla's more reliable network, so up till now, CCS drivers just had to put up with how terrible the other networks are. They literally don't have a choice. But soon they will. Once CCS drivers can choose Tesla's network, every other charging provider will need to get their act together or no one will use them and they will die. To be clear, I don't want them to die. And so long as they have half a brain somewhere in the C-suite, they'll grab hold of the lifeline Tesla just threw them. Making NACS a real standard and making it speak the same protocols as CCS means a simple cable swap will allow Electrify America or whoever else to sell their services to Tesla drivers. At least most Tesla drivers. I won't get into the fiasco that is the Tesla cars that can't speak CCS. Honestly, releasing their connector to the wild is without a doubt the most altruistic thing Tesla has ever done, and I applaud them for following through on their stated goal of accelerating electrification and not just their own sales. But now, back to what I had already scripted. Let me tee up the next sentence. While the transition to NACS might be pretty seamless, there is still a pretty big wrinkle though, and that's cars like mine. Hyundai and Kia decided to develop an 800-volt battery architecture for the eGMP platform. It's an amazing battery pack, and at least when I'm on the right charger, I have repeatedly experienced real-world charge times of less than 20 minutes. And while we now know that Tesla's connector can support charging at that voltage, literally none of Tesla's chargers in the US actually support battery pack voltages above 500 volts. This will slowly be changing though. Version 4 superchargers are able to output that voltage. However, as of now, none have been deployed in the US. Accordingly, companies that have invested in 800-volt architectures, mainly Hyundai, Kia, Porsche, and Lucid, aren't exactly in a rush to sign on to the NACS standard, because even once adapters are available, trips to a Tesla supercharger will be either painfully slow or just won't work at all for those cars. Many 800-volt cars have some provision to charge on 400-volt class DC fast chargers, but it's usually only a trickle. Until Tesla actually rolls out 1000-volt capable charging sites in large numbers, having support for NACS charging just doesn't matter for cars with 800-volt battery packs. That is, of course, only in the immediate term. And there's been some interesting news. A new, as yet unnamed, joint venture was recently announced between BMW, General Motors, Honda, Hyundai Kia, Mercedes-Benz, and Stellantis, which aims for a pretty ambitious charging network in the US. This network is going to support both CCS and NACS, presumably with each dispenser having 2 cables. And honestly, this is something that's important to touch on. The cable and plug are a small fraction of the expense in building a charging station. Adding support for both standards, especially since the comms will be the same, is therefore trivial. And in fact, Electrify America has already announced their intention to add the NACS connector to their chargers, since it is literally just a cable swap. The newly announced charging joint venture may wish to continue supporting CCS for their members' existing vehicles, or perhaps because it's currently a requirement to obtain government funding under the NEVI program. Regardless, the reason for CCS support on this new network doesn't really matter. But since supporting both plug types on the same charger is pretty easy, I'm not quite ready to say the death knell of CCS has rung. But again, NACS is certainly a nicer charging experience, so how long support for CCS continues is an open question. Once there truly is no downside to choosing to support NACS, then that's probably where most automakers will go. The future, as ever, is TBD. And now, the final section, where I get a little bit spicy. As if I successfully hid that before. So, Tesla definitely has the most reliable charging network right now. And for Tesla owners, it's a great experience. Tesla wrote the software on both sides of the equation, which not only ensures reliability, but also allows them to do stuff like use the car's infotainment screen for all charger-related needs, like, for instance, paying for charging. You can put your credit or debit cards into your Tesla wallet, or whatever they call it, and then pick which one you want to use for the charging session, all from the comfort of the driver's seat. Since that's all handled by the hardware in the car, the chargers themselves don't need any sort of user interface. They just have the plug, and when you stick it in your car, The charger knows which car it's plugged into, whether and how billing gets sorted, and then starts the charging session automatically. That is neat, I guess, but, and this might very well be an unpopular opinion, I don't care about that. Like, at all. In fact, I'm kind of actively against that becoming the norm and vehemently disagree with people who think this sort of technology, more generically known as plug and charge, is something every car and charging provider needs to support and embrace. And you want to know why I feel that way? Because perhaps it escaped your notice, but we've had payment solved for decades now. Call me a caveman if you will, but I still carry around this thing and it has these little plastic rectangles in it. And when I have to pay for things, I insert, or sometimes even just tap those little rectangles on a payment terminal, and golly gee, it works every time. A thing that seems to happen a lot in the electric car world, and specifically the Tesla world if I'm being honest, is the presumption that new and different always equals better. Meanwhile, outsiders are often more puzzled than they are enthused. To hopefully elucidate what I mean here, if I were to approach someone with a gas-powered car and say, "Hey there, I see you like fueling at Shell. Are you tired of having to use your payment card at every fill-up? Well, simply make an account with us, and with this little chip next to your car's fill hole, our pumps will automatically authorize payment and start filling." Do you think they'd be all that excited? Actually, ExxonMobil tried that back in the late 90s with Speed Pass. Remember that? It was a fob thing you'd stick on your keyring, so not quite the same thing as plug and charge, but since it only worked at certain gas stations and didn't really solve any problems, it wasn't all that popular. Plus, it ended up having some security vulnerabilities. Imagine that. And that's the key to my curmudgeonly take. Does plug and charge actually solve any problems? To someone who is used to the Tesla ecosystem, it sure looks like it does. Everybody agrees, including me, that plug and charge is miles better than the kludgy app experience we are often forced to deal with on other charging networks. And to lay my cards out on the line, I have used EVgo's auto charge system, which is technically different in weedsy ways that aren't worth getting into here, but it's basically the same. And yeah, I'll agree it's pretty neat to experience just plugging the car in and having the charge session start automatically. I get why you like that. But is that something I actually need? No, at most it saves maybe 10 seconds. At least if normal payments were actually an option that worked. Today's landscape, where Tesla's deep integration between vehicle and charging network stands against third-party networks that often rely on annoying and broken apps and might have a flaky payment card reader if you're lucky, presents us with an obviously false choice. But for some reason, a lot of folks don't see it that way. For example, I've run across countless people, both online and in person, who strongly believe Tesla's approach of removing as many points of failure as possible on their chargers, to the point of removing the user interface entirely, is the reason their network is so reliable, and thus support for plug and charge is the way every other network has to go. I think this is a reasonable position in a vacuum, but consider, if you will, just how incredibly weird and bonkers the current charging landscape actually is. Pretty much every public charging location, Tesla or otherwise, exists in the outskirts of some parking lot somewhere. They rarely have canopies protecting the equipment from the elements, they are almost always unattended, which makes them susceptible to vandalism, and even when they are co-located with another business, tending to the chargers is not something the employees of the Walmart are going to care about or even have the time for. Why is this important? Because I think we need to recognize that charging locations of today put the user-facing equipment in uniquely hostile environments. Tesla has done a good job of making charging reliable under such conditions, but in my opinion, those conditions are a result of the transitional period we are in, and not something I would expect to remain the norm. In fact, I really hope it doesn't. You know what I really miss when taking road trips in my electric car? Those little buckets with windshield squeegees. I still have to swing by gas stations just to clean my windows. And sure, Having a Walmart near the chargers is often quite handy, but it's usually a pretty long walk to the entrance to ensure shoppers don't take charging spots for normal parking spots. And boy, do I wish I could plug my car in well protected from rain and snow, like, gas stations do, almost as a rule. Canopies. It's like a roof over your head. And I also hope that drivers with disabilities will be able to expect an attendant to help them plug their car in when they need it, just like gas stations have today. Oh, and pull-through charging might be handy. Tesla wouldn't be dealing with Cablegate if they thought that one through. While I know some EV drivers loathe the idea that charging locations might start resembling gas stations, I am certain that that is going to happen eventually, at least along major highways. They'll probably look a little different. Maybe they'll have lounges and restaurants rather than convenience stores, though what exactly is wrong with a convenience store, I don't know. But people, including me, want a dedicated, well-lit, and staffed place to charge their cars. A place where they're protected from the elements while they plug in. A place where they can use the bathroom and grab a bite to eat. And a place where they can wash their dang windshields. If that sounds like a gas station, but with chargers rather than pumps, that's because that's exactly what that is. Why do you think gas stations look like that? It's because they have amenities that drivers need and want on site. I've said it before, and I'll say it again. Truck stop chains like Love's, Pilot, and Travel Centers of America are uniquely well positioned for cross-country EV charging. Luckily, some of them are starting to take advantage of that. And funnily enough, gas stations have never needed to resort to weird ways to pay for the gas they sell. Self-service pumps have robust payment card readers that rarely fail, and even if they do, the attendant on duty can attempt basic troubleshooting, or at least flag it for repair. Heck, you can even go inside and talk to that attendant and pay for your gas with cash. Remember that stuff? Sure, if you'd like to sign up for whatever loyalty program that particular brand of fueling station offers, that's by all means an option, but it's not necessary. If every car charger out there just accepted payments like a gas pump does, this whole discussion wouldn't even be happening. And personally, I don't want to sign up for yet another service that has my payment details and personal information. If you like the idea of plug and charge, cool. But I see it as a nice-to-have option, not a requirement, and I will actively avoid using charging networks which require me to sign up for something just to use it. Knowing that I'm repeating myself, a choice between chargers that support plug and charge and those which just accept normal payments is a false choice. If you're really that worried about charger reliability, then I suppose you can limit it to contactless payments on the dispenser and use like one of those little payment islands like you often find in parking lots for other payment methods. Or, have an attendant, like a gas station. If you're establishing a business which sells vehicle charging, don't make it weird, don't make people jump through hoops, just be a normal business, please. And I know there are costs to accepting card payments on site. Please don't assume I'm ignorant of that. I just view that as a basic cost of doing business, and trying to get around that is hostile to your customers. I do not want to normalize that reality. Where I think plug and charge actually has more merit is for public AC charging. Solving the charging problem for those who can't charge at home has always been the biggest barrier to EV adoption. And I'm personally pretty worried that we're going to view urban DC fast chargers as the solution. That is certainly an option, and there are a surprising number of people who are making that work, but it's not a smart use of resources. If people aren't able to charge where they keep their cars, that's the problem we need to solve, because that infrastructure is much cheaper and easier to deploy. The issue has always been one of how to pay for that infrastructure and charging. Landlords are never that excited to spend money in service of making their tenants' lives easier, so they're not exactly champing at the bit to install chargers. And that problem is even harder in neighborhoods with on-street parking. Personally, I wish power utilities would just step in and create their own low-powered charging networks for these situations, and I think plug and charge is a great fit there. A bank of on-street level 2 chargers that know which vehicles are plugged into them could simply direct the cost of a vehicle's charge session onto the electric bill of that vehicle owner. And with smart electric meters, those chargers could tap into the electrical supply of existing buildings without impacting the power bill of that building's occupants. Governments and electric utilities, you are free to use this idea. In fact, please do. Of course, there are other ways to make that scheme work. RFID tags on key fobs would be another way to start a charge session, and that might even be cheaper and easier to implement than plug-and charge. I don't know. All I'm hoping to get across here is that I actually think plug-and charge makes more sense for slow AC charging than it does DC fast charging locations along highways. I am all but certain DC fast charging locations are going to mimic gas stations before too long. And with the amenities and services they will likely provide in addition to charging cars, they're gonna need to accept normal card payments anyway. But that's the end of that rant. Again, if you like plug-and charge, by all means, have at it. I just don't want us careening to a place where that's the only way to start a charge. I'd rather just do it on my own, please. No signing up for anything extra, no fiddling with my car's infotainment screen when I want to use my work card for a work trip. Just normal payments. Figure it out. Literally every other industry has, and I do not buy your excuses. To summarize this video, it sure looks like NACS is the charging port of the future, and I think that's perfectly fine. It has always been a nicer plug, and now that we know it does match the capabilities of CCS, there's no reason not to use it here in North America. And nobody with a CCS-equipped car has reason to fear being left behind. Adapters will come one way or another. I really hope we don't continue down the road we're on of weird charger activation methods. Please just accept normal payments. Even vending machines now take cards almost as a rule. And in general, things are looking up. We still have plenty of problems to sort with electric vehicles, but the plug wars look to be at an end. Speaking of ends, this is the end. Okay, I lied. One footnote I want to throw in and almost forgot about is vehicle-to-X technology. A feature that has so far never been implemented on a Tesla vehicle, despite how amazingly high-tech and ahead of the curve their vehicles purportedly are, is a way to conveniently get the energy stored in their battery packs out of the car for purposes other than driving. For instance, my car offers vehicle to load, and this adapter will allow you to power anything that uses a standard household outlet through the vehicle's charge port. This is fantastic for emergencies, and I determined in a test that I could run my essentials for about a week from my car should I need to. We may never know why exactly Tesla hasn't bothered to implement this feature in their vehicles, but at least they'll sell you a Powerwall. Anyway, there is no technical reason vehicle-to-load or vehicle-to-grid technologies couldn't be implemented through the NACS connector, which is pretty much why I didn't talk about it, but I figure some folks would like me to speak to that. I have mixed feelings on vehicle-to-grid, as I think it's pretty tricky when it comes to battery wear and tear, but I certainly think vehicle-to-load is a must-have feature. Whether that's AC power backfeeding through the charge port like my car does, or connecting an external inverter to the car's battery pack through the DC pins like Ford does with their intelligent backup power system, the NACS port is certainly capable. It just has to actually be put into practice by an automaker daring enough to do so. Okay, now this is the end.